Good morning, everyone. This is Shiva from Soundbox Irrigation Design Services. So today we are going to discuss about pressure regulation in irrigation system. So we know that we have an component in irrigation design that pressure regulator. So it is usually attached with the drip zone assembly. Every drip zone assembly automatically comes with pressure regulator, but we need to add extra pressure regulator whenever it needs. So I'm going to discuss about that in uh, some amount of deeper. So hope you will enjoy this topic. And if you have any doubts, you can ask me anytime as always. So thank you. Let's get back into the session. So just I would like to just brush up everything. So what's pressure regulation? That we know the pressure regulation is the process of controlling the pressure over the system to the desired level. So it is majorly done. Why we are doing pressure regulation? It is majorly done to increase the system efficiency because whenever there is some pressure fluctuations in the particular system, so if for example if we have a head in particular place, so if it receives if in some time if it receives 30 psi, surely the flow will be in some amount. If it is 40 psi in some cases, surely the flow will be very higher than the 30 psi. So that's why we need to maintain the same amount of pressure everywhere. So that's how we can achieve the system efficiency. To say when we have a more pressure than the requirements, for example, uh, let's say spray heads usually operates at the 30 psi, but what if the spray heads receives more than 30 psi, like let's say if we have 50 psi, so what we need to do we need to reduce the pressure of particular spray head. How to reduce it? So we can achieve that with the help of the pressure regulators. So this is how the pressure regulators will be very useful to maintain the system efficiency. So, how the main objective of pressure regulation is, we know that water uniformity. We have discussed this in the day before yesterday's session, that how water uniformity has benefited us in cost wise, and also how it's very efficient to conserve the water. So we know that pressure regulation is to control the pressure. If we control the pressure, if we have maintained the pressure throughout the heads at same level, then obviously we will may achieve the higher uniformity. So that's the main ultimate goal of the pressure regulation. So we need to maintain the pressure regulator. We need to maintain the same pressure everywhere in the system, so that the each head uh, gives us the same amount of irrigation. Otherwise, for example, in the first head, if the first head of the lateral uh, gives us a lot of water, if the last head of the lateral gives us the low water, then the system is not uniform because we need to receive same amount of rainfall in everywhere. So that way we can achieve the uniformity. So I have attached this same concept in the same tabular column in the previous water uniformity session as well. As we know that the plant requirement, the plant rooting depth is only 11 inches. But whenever we have 70% uniformity, the water requirement per year is 42 million, 43 million over nearly 43 million. But whenever the system uniformity 85%, we drastically reduce to the requirement of water to 35 million. So it's a big change actually. So this is how we need to maintain the water uniformity with the help of pressure regulations. So in upcoming slide, I will discuss this in deeper. So for example, how this pressure regulation is very beneficial in slope areas. We know that this is the pivot irrigation, right? So we know that this is the very highly areas, and we know this is underrated area. Slope area and underrated both are equal. So in this area the pressure is very low, but in downside the pressure is very high because the slope is going down in usually. So the pressure is usually more at uh, the in the downside, but pressure is low compared to the downside in the upstream side. So we need to maintain the same amount of pressure everywhere throughout the cell, so that every head emits same amount of every gives the same amount of flow. Otherwise, if we have a different pressure in the each heads, obviously it will give a small amount of water. The downside heads give us the lot of amount of water. So this should be eliminated, otherwise, so that we can maintain the uniformity of the system. If this gives the 3 GPM, if lower side gives the 5 GPM, then obviously it is not the same. It is not a good uniformity irrigation system. Okay, So we need to eliminate this. So how we are going to eliminate this? So before that, I'm just giving you the visualize the picture. You see this. This pivot irrigation is without um, pressure regulator. So as I mentioned here, you know this. In the top area, the pressure is low, but in down area, the pressure is high. So what happened here? Though? So if pressure is low, then obviously the flow will be very low. So that we have only received this amount of depth. But see this, in the down area we have a lot of pressure, so flow will be higher, so that we receive this amount of depth. So understand the difference between, if we maintain the pressure regulator, if you attach the pressure regulator in every head, we know that we have maintained the equal depth in every side. So let it be a downside, let it be a higher side, let it be a lower side, let it be a higher side. So we are maintaining equal depth. But if you are in this condition without pressure regulator, in the lower side we are receiving more irrigation, but in higher side we are receiving only little bit amount of rainfall. So this is the difference between uh, with usage of pressure regulators and non-usage of pressure regulators. So this is how they are attaching this pressure regulator to the in the pivot irrigation. They are just attaching. This is the inline line. From this water comes to this pipe. So we are attaching pressure regulator here. So when we are attaching this, even though it is, let's consider this is at the lower side. So even though the pressure is 50 psi, it only allows the 30 psi to come outside, so that the heads receive the same amount of water. So this is how we need to maintain the uniformity, and we will save the lot of cost for the water bill. So I hope you have understand the importance of pressure regulations in these with these pictures. So and in this picture we are using this in day-to-day life. So we are just placing this, we have placed this heads with the help of the riser. So no issues. One more issues with the too, if we are supplying the too much pressure, obviously the system heads will emit mist. It start to mist. It doesn't give the droplets. It will start to give us the mist if the pressure is too high. So obviously the vector diameter is only this up to this level to this, but we have targeted this up to this area to this area. But in this condition it just wetted this area only. And one more thing is the water is very the droplet size of the water is very small in this condition. So wind will easily blow away this water, and it will not give us the equal distribution of water. And one more thing is a lot of water gets evaporated due to this, because the small better diameter small droplets can be easily evaporated in the sunny conditions. So we need to maintain the same pressure in everywhere. If we supply too much pressure, then obviously the head will start to mist the water. Then if you are maintaining the normal pressure, obviously it will give us the some kind of equal amount of droplets, and which will not be carried away by the winds, and it will cover the expected area, so that we have to maintain the equal pressure. So normal pressure. And yeah, I'm in this picture I just give you the picture of how this pressure regulator is working. So when this is flow inlet, and when the water gets inside this area gets converged. So if this area gets converged, what happens? So the velocity of the water will increase. So let's assume that this is the 2 inch and this is 1 inch. When we are shrinking the size of flow, obviously the velocity of water will get reduced. So if velocity increases, the pressure automatically decreases. So this is the principle behind this. And this spring is used to absorb the thrust because of the pressure regulation. So obviously these pressure regulations will be beneficial for every grower. And in this picture, yeah, I just give you the video of working of this pressure regulation. Look at this. The water is flowing rapidly here. If you see this picture, the water is coming slowly. Once it reaches this area, it starts to move rapidly, because the area is very uh, convergent. So but here it comes slowly. Water here comes slowly, but here it moves fastly. So this is the concept of pressure regulation. So we need to reduce the pressure by increasing the velocity. So the next slide I just give you the This is the PGP of Hunter products. We know that when it is operating at 30 psi, it only gives 0.5 GPM. When it is operating at 0.6, operating at 40 psi, it gives us 0.6 GPM. So when it is 50, it is 0.7. So this is the manufacturer's recommendation. So we need to maintain the 50 psi everywhere in the system. So it is very difficult to maintain that. So how to maintain the same pressure in every head? So this is we can do that with the help of pressure regulators. So uh, mm, this is how the pressure regulator is very important to us. And one more thing. So this is the red nozzle. This is blue nozzle. The mainly uh, flow varies, right? Okay. So I hope you have understand something about this performance data. So I hope you have learned something about these pressure regulations. And nowadays we are coming with PRS regulator, pressure regulator system have attached to the heads itself. So we don't need to install this pressure regulations in inline valves. So PRS valves only allows PRS heads only allows the equal amount of pressure in every head. So we don't need to concern about the pressure regulations in with separate pressure regulations in inline lines. So obviously this PRS heads will be a breakthrough for the every grower. So thank you for joining today. If you have any doubts, you can ask me anytime. So we are Soundbox Irrigation Design Services. So thank you. Bye bye.